Good morning to all. Today we can discuss about Cascode amplifier based on BJT in the subject analog electronics. A BJT based Cascode amplifier is a two-stage amplifier. So the two-stage amplifier that uses bipolar junction transistors to improve the input-output isolation and bandwidth. These are the two main advantages of using this Cascode amplifier. One is improves input-output isolation and another one is bandwidth. So it is made up of the two stages. One is common emitter followed by common base stage. So the circuit diagram is shown. The first one is the common emitter stage, that is Q1, and Q2 is the common base stage, and the input is given to the only the base of your Q1. That is your since in common emitter, base is the input side. So in the to the base, it is given with the input signal, and this bypass capacitor CE and CB, CC1 or the coupling capacitor, CC2 is also the output side coupling capacitor. So these are this resistors form as a divider for biasing R1, R2, R3, and this is given in this region. So RE is used to make Q point adjustable. That is the bypass capacitor, and the AC output voltage is obtained at RC collector coupling capacitor are used to block DC signal. And R1, R2, R3, RE are used to bias transistors Q1 and Q2 in active region. Because in active region only the amplification happens. And the AC signal is supplied at the base of Q1, which amplifies with the unity gain, and the voltage V01 appears across collector of Q1. This output, so the output V01 obtained at Q1 is fed as input to the second stage. What is the second stage? Common base. In the common base, you will be having this will be acting as input. So as input to Q2, which further amplifies the signal, and the voltage V0 appears across collector of common base configuration. That is the second stage. So how it is going to work is the common emitter amplifier has a relatively high, this first stage has high input resistance. And the second stage common base amplifier has a very low input resistance. So both drives, this is CE drives the CB for both AC and DC inputs. So the lack of direct coupling from output to input eliminates the Miller effect. Since we need there is no need of any capacitance between the connection between the output of Q1 and Q2. And so the Miller effect is when a small input capacitance appears, a much larger other input to an of an amplifier. So because of this, what you are going to achieve is you are going to achieve high input impedance, because CE has this effect, and output impedance is higher in CB. So these are the major advantages of cascading these two types. So good gain and bandwidth. So mainly how it is going to be analyzed is, first we have to convert this to hybrid model. So that is equivalent circuit. To draw AC equivalent circuit of the given amplifier, we have to go for all capacitance must be short circuited, and DC sources must be connected to the ground. So this diagram shows here. So input the current source IS is converted to voltage source. So R1, this R3, R2 is connected parallel. This R1 is short circuited, since capacitor is the CB is short circuited. Okay. So next is the equivalent for the transistor 1. So for the transistor 1, it is replaced by R pi 1, GM1, V pi 1 for this Q1. Okay. So the base terminal B1, E1 and C1 are marked. And next comes the transistor Q2. For this again, R pi 2, V pi 2 based on the direction we have drawn. And in the output side, since CC2 is short circuited, you have that RC and the RL. So RC is connected in parallel with RL. And the base terminals emitted to, collected to, base 2 are marked here. Okay, and the output is given. So this is your hybrid equivalent model, and from this we have to go for calculating the input resistance, output voltage, and the gain. Okay. So first you are going to what is gain? We know output voltage by input voltage. So we have by Vs. Okay. So from the input circuit, V pi 1, since the potential at this base 1 is Vs, so V pi 1 is equal to Vs. And from the output circuit, what is V naught? We can calculate it as the current source is Gm2 V pi 2, which divides between the RC and RL. Okay, so it is minus GM2. Why it is minus GM2? The direction is opposite side. So minus GM2 V pi 2 into RC parallel RL. Okay, so what is the aim? To find your V naught by Vs. Okay, so we are going to apply KCL at emitter 2 terminal. So you can see from the diagram, emitter 2 diagram, what you can obtain is the incoming current source is GM2 V pi 2 and this R pi 2 V pi 2 and GM1 V pi 1 are the leaving currents. So we are going to GM1 V pi 1 is equal to the voltage current across this R pi 2 is V pi 2 by R pi 2 plus GM2 V pi 2. Okay, so from that expression, you can find V pi 2 because we can substitute this V pi 2 in this equation number 2. So you are going to do the simple calculations to find V pi 2 and you are going to substitute GM2 into V pi 2 as beta 2. So you have found out V pi 2. Now substitute that V pi 2 equation in 2. So it becomes minus GM2 R by 2 by 1 plus beta 2 GM1 into Vs RC parallel. Now from this we can calculate V naught by Vs, that is the gain. So that is your output, voltage gain. Next thing is you have to find input resistance, output resistance. So in the input side you have R2 parallel, R3 parallel, R by 1. Directly we can write. For the calculation of the output resistance, from the output resistance itself, we can know that RC is parallel with the RL output side. So it is nothing but R not equal to RC parallel RL. So this is the simplest analysis of the cascode amplifier. And this cascode amplifier is used in all broadband applications because we have enhanced the bandwidth of the and the gain and the bandwidth. So all the broadband applications use this cascode amplifiers. Thank you.